Today, we are, and folks, the reason why I go through these learning goals, again, it's for you to understand sort of the finish line of this lesson, right? So at the end, you almost like you check in with the learning goals again and you're like, did I learn these things? Or even at the end of doing homework, do I understand these concepts? Because these are the concepts of today's lesson. You look great, but please put your telephone away. Like put it away so it's not going to distract you. Okay, add and subtract rational expressions by finding a common denominator involving a variable or binomial. So it's all about the common denominator today, and it's all about adding more factors like we did in the warm up. Multiply the numerator and denominator by whatever that new factor is. Okay. So let's just get going. Now, I will return your quiz at the end of the lesson. And one of the things that I noticed when students don't know what to do is or how about this? If you don't know what to do and you're given a trinomial, what can you do? Just factor it, right? If I'm asking about the volume or like how long it takes for something to get to space, but I gave you a trinomial, just factor it, right? Even that will give you some marks. So in those thinking inquiry questions, do the same thing you've been doing in your homework, right? Factor, factor, factor. So when you see a trinomial, factor it. Okay, must factor. You see a binomial, try to factor it. Okay, so let's look at this first example. So here we have two rational expressions that we are subtracting from another. Now, again, in the test, there might have been a question that said rational expression that used that term. Also, in the communication question, I think it was a bit easy on you folks. Like if you didn't use a specific term, but you described it, I gave you the mark. But moving forward, I want to see the terms that are presented in class. So rational expression, do you know how to use that in a sentence? Restrictions, undefined, all those terms. Like I would actually keep a list, a little like vocab list, and review that before the test, because if there's a communication question, you are expected to be using the correct terminology. Does that make sense? Okay. Sorry, the last thing I want to say, I've ordered some highlighters, and I will be offering them during tests so that you can use a highlighter to read the question really carefully and highlight the important stuff so that you actually answer the question. Okay, sometimes students lose marks that way. All right, so I'm going to show you how I do my active reading. It says simplify and state restrictions. So I'm double underlining restrictions to make sure that I do it. Okay. Okay, well, simplify, what does that mean? Probably means to factor. It means make it smaller. So what do I got here? Okay, let's look at the first rational expression. Can I factor the numerator? I cannot. 4x minus 5 remains. Okay, and with the denominator, again, it is in simplest terms 2 times x, right? That's basically a prime number. Cannot be divided anymore. Okay, let's look at the second term. Again, the numerator cannot be factored. There are no common factors. And the denominator, so it can't be factored, but we can break it down more, right? What can we break it down to? Consider what we just did on the boards. What can I break 3x squared into? 3 is a prime number. Not just x. Yeah, x times x, right? So same thing, but based on what we just did in our warm-up, what are you going to multiply this purple rational expression with? 3x. So this one has a 2x. Okay, they both have an x in common, but there's no 3, so I have to multiply by 3. Wait, I want more space. So I'm going to multiply this one by 3 and 3. And because there are two x's here and only one x in this denominator, it means I will multiply the first rational expression by 3x. Okay, which factor is missing from the second denominator? Yeah, so I have to multiply the second rational expression by 2 and 2. And so now when I look at those denominators, I'm like, okay, each of them has two x's, each of them has a 2 and a 3. We're good. And so now we can combine the denominator. So the denominator is 2 times 3, x times x. So we've got 6x squared as the common denominator. Yeah? Okay. And now for the numerator, I'm going to take a few steps here. I've got 3x times 4x minus 5 and negative 2 times, actually, I'll do it maybe the way you would do it. 2x plus 3 times 2. Now, we know that when we multiply, the order doesn't matter, so you could have put the 2 in front, but let's say you didn't. Okay, what is a mistake that we might encounter here? Yeah. That's it, right? It's that minus. We might just, you might multiply, you might go like, okay, that's 4x plus 6, and then you might not expand, you might not multiply the constant by the negative. Okay, so that's why taking these extra steps might help us avoid that. All right, so let's have everyone work on this next line. Sebastian, 10 more minutes. All right, let's keep going. Anyone disagree? Maybe I made a mistake. Okay, anyone got this too? Okay, thank you. Are we done? No. What else can we do? We can state restrictions, but anyone else tempted to do something? Yeah. Let's check. Okay, I don't know if we can, but we're always going to check if we can factor this trinomial. So for that trinomial, I'm looking for numbers that add up to negative 19 and multiply to negative, is it 72? Yeah, it's 72. So they multiply to negative 72 and they add up to negative 19. Okay. For 72, I know it's 36 times 2. That would also be 18 times 4. What is it? That's right. 8 and 9. Any of those give me 19? No. Okay, we tried. Good. I love that. I love seeing that you thought, hey, maybe we can factor it. Excellent. All right, but now we do need to state the restrictions. What is the restriction? X cannot be equal to null, 0. That's the only one, right? All right, let's try. Are we good? Folks, I'm curious. What type of which part of this might be confusing? Actually, don't tell me. Elian, you're going to turn around, and I want you to talk with your partner, Claire, you're going to turn around, about what would be something that would be confusing about this part, about this question. Okay. Are we good, folks? Any questions arise? Excellent. Let's move on. Okay. So I want everyone to read this question using active reading. So you're reading the question, you're underlining, you're circling. Yeah. Okay, we're good. Okay. Before we start, I want you to talk with your group partners about what is the approach here. How are we going to approach this question? Go. Don't just say common denominator. Come on, give me more. Marley's like, I don't take that. Give me more information. All right, talk. Zach, does that make sense? Okay. All right, folks. How many people think I see people working. Who wants to try this on their own? Whoa. Really? Yeah, I would love to see you. So, folks, what I would encourage you is do this. Use half the page, okay, to try it on your own. And if you make a mistake, no worries. You're using a pencil, right? But you're going to learn so much more if you make a mistake and then learn from that mistake. So try it on half the page, okay? And then I'll take it up, and you can redo it if you did it completely wrong, or just fix your mistakes. Yeah? Okay. Give it a shot. Не знаешь, что почати? Polly, do you have an idea of how to start?
I'm trying.
What are you trying to do? Because Angelina has no idea where to start.
Yeah, no, sometimes like 18. Okay, so
Folks, should I start putting the solution on the board? Yeah, and then I can walk you through it slowly. I will work very slowly. So is this helpful? Step one, right? We all common factored, or if not, right? Remember when I jumped off the desk and I said, check for common factor. So Liam, how are you going to remember it? Do you need to get up on your desk and jump off and say, check for common factor? I think so. And then he won't. Gosh.
Can I?
Why not? If it's going to, like, I'm not kidding. If it's going to help you remember it, do it. Do it right now.
Maybe not.
Oh, come on.
Oh, wait, can I actually?
Yes.
Wait, on top of my desk?
Just don't injure yourself. Who else needs to do it? Come on. All right, say it.
Check for common factors.
Woo! All right. This is a thing, folks. Okay, who here forgets where they put their phone somewhere? Who's the person that forgets where they put their phone? Okay, I'm gonna teach you something I learned because I forget it all the time. Don't just put your phone like that. This is what you do. Put it down, and you do some kind of action. And as soon as you do an action, it kind of commits it to your brain better. So what Liam just did is he did an action to commit. Don't forget to common factor. That was excellent. Good. Am I? I heard that. That's kind of funny. I'll take it as a compliment. All right. So, I need a lot of space. But doesn't it make math class a little more interesting? Right? Otherwise, it would be just so boring. Imagine you had a regular math teacher. All right, folks. So, what we've done here is we've broken it down into factors. And now I'm just looking at which factors are missing. So, in the beautiful teal one, what's the factor that's missing in the denominator? A 2. Like, let's look at this, folks. There are 3m minus 2, 2m minus 2, 1. Do I need to include 1? No. So the only one that's missing in the second one is a 2 over 2. Now it has all of them. And I'm just going to use colors so that you see where these factors are coming from. The second rational expression is also missing a factor. Which one is it? The 3, the nice teal 3. And the purple one is missing a lot, right? It's missing a 2, an m minus 2, and a 3. Can you change the order? Absolutely. Does this look confusing? Would it be better? Yeah, I feel like it looks confusing. Would it be better to put just all the numbers together and then the m minus 2? Or just 6? Just 6? All right. So we're just going to write 6 over 6 and then m minus 2 over m minus 2. Now, I'm going to put brackets because I want to make sure I don't make a mistake. And so now we check, does every single denominator equal to 6m minus 2? Yes, it does. Okay. So we've got 6m minus 2. And so this is where, again, we might make a mistake in forgetting that this 2 is distributed in both of these, right? So you can skip this next step, especially as these questions get more complex. You can skip that, right? I'll show it. Minus 3m. I want color. Plus 6m m minus 2. Are we good? And now it's like, oh, this is stuff from before, right? Now we know what we're doing from this point on. It's really, I would say, this is the big step, right? That's the new step for today. Page 13. Okay, so in the denominator now, folks, I'm not expanding. I'm keeping it factored in case there's something I can cancel out. So I've got 2m plus 16 minus 3m plus 6m squared minus 12m. I'm really hoping I get to cancel something out because I want it as simplified as possible. Ask. You have a wonderful question. Do you want to ask it? So then I got, for the m's, I've got positive, -1. So I got negative 13m. Oh, that's not. And then I've got plus 16.
Why can't you cancel out in the first step that minus 2?
Like back here?
Yeah, like
Okay.
the first
Can you tell me why?
because
So you can't, right? So the great question is why can't. Say it again.
is the minus separates the fraction.
It's because there's a plus and a minus here. If it was this times this times this times this times this, then you could. But we are adding polynomials here. So I want to get all the way to bottom to see. So folks, I'm now going to check, can I factor this, right? Zach was telling me, he's like, Miss Sly, make sure you check if you can factor this. So I'm looking for two numbers that add up to equal negative 13 and multiply to give me, try this in your head, folks. Did you do it? Good for you. 96. Okay, so 96 is going to be 3 times 32, is it? What else? 48. 2 times 48. 4 times 24. 8 times 12. Any of them give me 13? No, right? I think that's it. All right, so we can't factor it. Are we done? I don't know. I'm going to look back at my active reading. Oh, Miss Sly, thank goodness you did active reading because you circled the word restrictions, and I almost forgot. All right. What's my only restriction?
2.
That's correct. M cannot equal dos. Yes.
At the beginning, when in the original statement, it says m plus 8 over 3m minus 6. Wouldn't you have to do I don't know.
Did you answer your own question?
No, I just don't know.
Okay.
It's the same.
All right, folks. Are we ready for the Whopper? And just notice how much space we are given for this question. Aren't we excited? Oh, yeah. Who wants to work on this on their own? Yeah, do you want to? Who feels they can? Oh, how about this? You look at this, you're like, I don't know what to do. This is too ugly. I want to this is gross. What can you do? What can you do, Marley? You have no idea what to do, but you see a trinomial. What can you do? You can factor, can you not? And isn't that what we did in the warm-up when we just had integers? We factored. Oh, interesting. All right, let's try that. Hinner ти знаеш що робити? Почни. Дивись, ти не знаєш, що робити, але ти можеш принаймні factor, правда? Did anyone see the shortcut? What is it? What is it?
Square binomial.
PST, perfect square trinomial. Yeah, good. If you didn't see it, that's okay. You still get there. Right? You're always going to get marks for just factoring. unless I say, don't factor. Give yourself a lot of space. Folks, how many people are able to get this far? Where you've just factored the trinomials. Excellent. That is the first step. And now when you think back to what we did with the integers, do you know what to do here? Who knows what to do? We're going to check to make sure that each rational expression has the exact same denominator, meaning they need to have the same factors. So let's look at the red one. The red one has 2x plus 2's, okay? The blue one has 1x plus 2, and then like one of these, and it has one of these, x minus 7. So if I look at this first one, which one is the one that's missing? Yeah, right? So I'm going to bring this, so I'm going to multiply. I'm going to multiply this rational expression by the factor that is missing. And then if I look at the turquoise one, or the teal one, which factor is missing? X plus 2. You can't just say, oh, look, there's an x plus 2, and they have x plus 2's. No, look here, there's 2 of them. So because there's 2x plus 2's in the denominator, that means this teal one needs to have 2 factors of x plus 2. And notice I'm using brackets. Use brackets like a lot. Okay, it's. I feel like that's the safer bet. Okay, now here's the question. Are you multiplying all 3 binomials? Don't expand unless you think you really should. Okay, the default is, the default is keep it factored. That is more simplified. Okay, so what do we have now? Now, watch my fancy math, right? Oh, Miss Sly, she's so good. So good. I would never have thought of that. Man. Thanks, Sophie. I heard your inner voice. You were like, she's so good. Okay. And now the numerator. Okay, don't go crazy. Don't overthink it. The numerator, we're just expanding, right? 3 times x, 3 times minus 7, right? We're just expanding. Yes.
Could you do like x minus 7 and then x plus 2 and then we brackets 3 minus. Oh, never mind.
Great question, and you figured out the answer on your own. Love it. Okay, who can tell me this? 5 points for whoever can tell me why I cannot do that. Actually, I want you tell the. Okay, we're gonna do it like this. If you're sitting closer to the door, Julian, Sophie, Amelia, Astrid, your job is to tell your window partner the answer. Why can I not do that? And Sebastian dropped the course, so I'm going to change the seating plan so that you have a partner. Do you know why you can't do that? It's because we're adding something. Can you see? Can you see the board? The crossing out, the purple lines. Why can I not cross out the x minus 7? Good. All right, folks. Okay, let's see. Victoria, we're going to see how well you listened to your partner, because your partner has so much to say. All right, listen up, listen up. We've got wisdom. Victoria, why can't I cross that out? That's right. And that's what my partner told me. Because we are subtracting this and this. Can I tell you, folks, this is a very common mistake, right? So if you want to make a note, let's make a note. Cannot cancel x minus 7. Gotta make it look pretty. Or x plus 2, right? X plus 2 is the same situation because numerator has subtraction. Okay. So I'm going to take these purple lines away because we can't do that. All right, so let's finish up this question because I want to give you your quizzes back. We got 3x minus 21 minus 5x minus 10 over x plus 2 squared times x minus 7. What does that give me? 3x minus negative 2x minus 31. Does that make sense? Okay. And Zach, what am I checking for? Yeah, I'm always checking, can I factor more? Can I factor? No. So we leave it like this. You do not need to expand it. That would look ugly and actually not simplified. This is more simplified. All right, what am I missing, Lily? You got it. And if I forget, I didn't circle it. Yeah. X cannot equal to negative 2, positive 7. I'm going to go up to see if there was anything else. Okay, negative 2, positive 7. Okay, I've taken care of everything. Now, for those of you, yes?
What happened to the other x minus 7? Like the
Oh, yeah.
over.
So I brought, like this one?
Yeah.
So I brought the denominator, because the denominators are identical, now I can have one denominator.
Oh, I see.
Yeah, great question. So folks, for those of you who are like, we've got a long weekend, I can't wait to do math all weekend long. Well, sorry, I should have said for all of you. You can work on this whopper of a question. Will this help you digest the thinking inquiry question on the test? For sure, you're training your brain, right? This is fun. Give it a shot. We'll take this up on Tuesday. So let me give you your quizzes back.